This is a short little video covering how to calculate a confidence interval for a population proportion. We're going to use a four-step process with state, plan, do, and conclude. So first, we're going to read the context, and then we're going to state what we're about to do and the parameter of interest and things like that. So the context here is there's a certain high-profile national leader that's not known for consistently telling the truth. And there's an activist group that gathered a random sample of 350 statements made by this leader, and 310 contained a distortion of truth, or in many cases a direct lie. So we're interested in the overall proportion of statements made by this national leader that contain a distortion of truth. And we want to estimate this proportion at a 90% confidence level. So first, even though it was kind of handed to us, we're going to intentionally state the parameter of interest. So we write it down that we're interested in the proportion of all statements, and the key word there is all. That indicates that it's a parameter, not just the sample proportion. So all statements made by this national leader that contain a distortion of the truth, and we're going to construct a 90% confidence interval. Next, when we to lay out the plan, really what we're asking is, we know what we want to do, but should we do it? Have the conditions been met? And we need to verify these in context. So we want to first clarify. We want to lay out the assumptions we need to make and then check in context whether they've been met. So are the observations independent in this context? So we want to look for, was it a simple random sample, or was it at least a random sample? And is it small compared to the population? So it was stated that it was a random sample, and we have to assume that there are a lot of statements made by this leader, so that 350 statements represents no more than a tenth of the population. So we're going to write those down. Next, we need to go and check if our sample size was large enough, and we want it to be large enough so that we can use a normal model, the normal distribution. So in this context, that means that we need to be able to expect at least 10 yeses and 10 nos. So of the 350 statements, we observed 310 yeses and 40 nos. Both of those are larger than 10. So our sample size is large enough. Next, we can carry out the procedure. So we're going to write down our sample statistic, and we're going to calculate the standard deviation, or the standard error in this case, and we'll calculate the margin of error, and we'll put it all together. First, our sample statistic is just the proportion from the sample, so 310 out of 350, and we get 0.886 when we round it. And the standard error, the formula is p 1 minus p over n, all of that square rooted. The hardest thing is just entering that in the calculator, but we get 0.017. So typical samples of this size in these conditions will differ from the true center by about 1.7%. Next, we need to figure out how many standard errors we should go away from our sample statistic so that we capture 90% of the bell curve of the normal distribution to get us a 90% confidence. As a quick aside, what that really means then is if I want the middle 90%, and I'm thinking in terms of standard normal here with a mean of 0 and a standard deviation of 1, I want the middle 90%. The tool I have is an inverse normal distribution, which is going to capture the middle 90% plus this tail. So this tail is 5%, and this tail is 5%. So I want to find some value where 90% plus this 5% is to the left. So when I switch back here, I'm looking for inverse norm 0.95, and I get 1.645. So to capture the middle 90%, we need to go 1.645 standard errors on either side of center of the mean. So that's called the margin of error. And so 1.645 times the standard error is 0.028. So the confidence interval is as simple as our sample statistic, which in this case is the sample proportion, and we add and subtract the margin of error, 0.028. And doing that, we get 0.858 to 0.914. So that's the do step. We crunch the numbers. And finally, we write a conclusion in context. It would sound something like this. We can be 90% confident that the proportion of all statements made by this national leader that contain a distortion of the truth is between 0.858 and 0.914. And again, there's the word all. We're not confident, we're not trying to make a confidence interval for our sample. It's the proportion of all, the population parameter that we're trying to estimate here. And so that needs to be captured in the conclusion.